Good day. Today we will be presenting the research of Dr. Anna Valero from LSE and Dr. John van Rennen from MIT. Their paper, The Economic Impact of Universities, Evidence from Across the Globe, explores the research question, how is university formation correlated with future economic growth? Through an extensive panel regression analysis, they validated the pivotal role of universities as a driver of economic development and its mechanisms. Their findings not only made a significant contribution to the labor economics and innovation economics literature, but also had critical implications for policymakers. Throughout this presentation, we delve deeper into Dr. Valero and Dr. van Rennen's methodology, explore their findings in detail, and discuss their implications. So let us embark on a journey and discover how this paper sheds light on fresh perspectives on understanding the role of education in fostering long-term prosperity. So why is this topic interesting? Let's look into some statistics. Globally, university enrollment has surged from 1 in 100 in 1900 to 1 in 5 by 2000, demonstrating a growing democratization of higher education. This impacts individuals, societies, and most importantly, economies. Although there is extensive literature on human capital and economic growth, the authors identified a critical gap. That is, the existing literature fails to address the specific economic impact of universities. Therefore, this paper fills this gap by examining the direct link between university presence and economic performance. Notably, the strength of the analysis is in the comprehensiveness of the dataset across different regions and times, and the associations we document should be seen as suggestive rather than as definite conclusions.
Before we delve into the main analysis, let's formally define the hypotheses stated in this paper. The main objective of the research is to verify that the increase in the number of universities within a region will have a positive impact on driving GDP per capita growth in future periods. The authors then hypothesized 4 mechanisms as to how universities might drive economic growth. The first being the human capital hypothesis. The rationale behind this was that universities produce skilled workers, and skilled workers are more productive than unskilled workers. This higher productivity in human capital helps drive economic development. Second being the innovation hypothesis. So universities increase the local innovative capacity when they directly produce innovations and collaborate with local firms. The technology spillover effects have the potential to generate multiplier effects for the economy. Third being the democratic value hypothesis. Here, universities are stated to have a significant role of fostering pro-growth institutions because universities usually provide a platform for democratic dialogue and the sharing of ideas to take place. With this, the increase in individuals with such pro-growth ideologies instilled within them will facilitate economic growth when they join the labor force. Finally, we have the demand effect hypothesis. The authors considered the possibility of whether the GDP increase could be solely originating from the material impact of increased consumptions and investments in universities. So to test these hypotheses, the authors of this paper utilized the World Higher Education Database, extracting data points from 1,500 regions across 78 countries, spanning from 1955 to the year 2000. This totals 14,848 observations of universities included in this analysis. The 2 diagrams here present some descriptive statistics. On the left, we observe the evolution of the number of universities over time. We can see that in the mid-19th century, there was exponential growth, which is why it's an interesting time frame to study. On the right, we see a similar trend when the number of universities is normalized with the global population growth. When running a correlation matrix, the authors found a strong correlation between universities and the average years of schooling, patent applications, and democracy. This provided a compelling foundation to study the mechanisms through which universities might drive GDP growth, as hypothesized by the authors. However, a more sophisticated econometric approach was necessary to validate the research question. So this brings us to the empirical framework. The authors used a panel regression with fixed effects to investigate how university formation drives future economic growth. Therefore, the dependent variable is GDP per capita, and the main regressor of interest is the number of universities within the region. Notice that the time subscript for the uni variable is t-5. This is used to estimate the lagged effects of universities on GDP growth because intuitively, it is unlikely for economic effects to be immediately realized after the formation of a university. 5 years is a justified number because most students would have graduated at this point and GDP per capita Growth rates are usually estimated in 5-year blocks. The equation also includes other controls like population levels, lagged population levels, country and regional GDP levels per capita, which are captured in the X variable. Other than that, the empirical framework captures regional fixed effects in eta and the time dummies in tau, which capture the region-specific time effects. Finally, the epsilon represents the error term that captures any residuals.
Before we go into the details of the results, let's have an overview. The main research question was validated, meaning to say that the number of universities indeed leads to an upward growth in the GDP per capita growth. With the 4 mechanisms briefly discussed, 3 or 4 of them are proven to be true. The human capital and innovation hypothesis both found small but significant correlations. The democratic value hypothesis was proven to be strongly correlated, suggesting its strong role in shaping institutions, especially in the long run. However, the demand effects hypothesis was disproved. Let's first look into the main findings. The coefficient of interest here is the coefficient of the main regressor, like growth in number of universities, highlighted in the table here. In the first column of the simple bivariate regression, it is found that a 10% increase in the number of universities in a region is associated with around 0.47% higher GDP per capita. And the inclusion of controls and fixed effects in the following columns does not affect the main coefficient much. The only notable fluctuation is in column 9, which includes a full set of country by year dummies, where the coefficient drops to 0.23%, but it is still highly significant. Overall, with the specific to general breakdown, the model averages to a 0.4% increase in GDP per capita for every 10% increase in the number of universities. This interpretation is significant to the 1% level. All in all, strong empirical evidence supports the main hypothesis. Next, the understanding of human capital mobility suggests that universities' economic impact should extend beyond the local region, and is likely to generate spillover effects into neighboring areas. This motivated the authors to allow scope for spatial variation in their model. By isolating the sample, they found that a 10% increase in the universities in the rest of the country brings a 0.6% increase in home regions' GDP per capita. So geographically closer regions have stronger effects on each other. Now that we have proven there is indeed a strong causal relationship between universities and future GDP growth, we begin to scrutinize the mechanism behind this. Firstly, to test the human capital hypothesis, lagged and current growths in college shares are added as controls. In all cases, the coefficient of interest is small in magnitude, but is still highly significant. It is highlighted in the table here. This means universities do play a significant role at increasing the supply of human capital that directly generates GDP for the future economy. Secondly, patents are used as a proxy to measure innovation when testing the innovation hypothesis. Notably, in the table here, we observe a 10% increase in the patent stock associated with a 0.5% higher GDP per capita. This means that innovation is indeed an important explanation as to how universities contribute to the regional GDP growth. But it does not explain everything. This could be due to the benefits of innovations generated needing a longer period than 5 years to be realized. To test the effect universities have on democratic values, the authors ran a separate regression with a categorical variable, approval of democracy. Evidently, there is a strong positive relationship between an individual's education and the approval of democracy, verifying universities' strong role in shaping institutions. This directly implies that democratic ideals from universities have a spillover effect into their surrounding regions, affecting the regional economic growth. However, it does seem that this mechanism is only proven in the longer time horizons. As seen in the table here, it takes a 15-year time lag to prove so. Lastly, the authors hypothesized that it could be that the establishment of universities only have a mechanical impact on the economy, i.e. from consumption and investments as seen in the equation below. However, they used some simple calculations to demonstrate that the direct effects from consumption and investments are actually insufficient to explain the correlation. Hence, this is the only hypothesized mechanism that is dismissed and disproved in this paper.
To confirm the robustness of the results, the authors employed 4 types of checks, namely specification and sample checks, heterogeneity checks, augmentations to account for the university size and quality, and running a barrel growth regression model. Firstly, specification and sample checks. With the sample empirical framework, the authors checked for specification issues, sampling issues, and measurement issues. The authors went into great detail by controlling for population share, dropping regions with no universities, using alternative measures to capture variables, etc. All of which proved that the results remained robust. They also ran a Granger causality test to prove that there's no reverse causality in the research question, i.e., it is not GDP per capita driving the number of universities in a region. Next, to check for the heterogeneity in the sample, the authors examined the sample by region. All regions remained to prove to have a positive association with university growth and GDP per capita growth. Further scrutinizing this by time periods, it is interesting to see that in Asian countries, the effect is only more prominent in the post-1900 period. Zooming into the within-country effects, the establishment of new universities tend to have a stronger economic impact in poorer regions of a country than richer regions. The authors also took into account the heterogeneity of universities in terms of size and quality. To control for the size of universities, they examined the relationship between growth of universities and growth in enrollment. The positive relationship verifies that using the number of universities in the main model of this paper is appropriate. As for the quality of universities, the authors looked into a sample of research-based universities. The results for the main research question remains the same, but the most interesting finding here is that the innovation hypothesis seems to be a stronger driver of GDP per capita growth in countries that are more technologically advanced. Lastly, the authors also tested the hypothesis with an alternative economic approach, that is the barrel growth regression model. This model is a slightly different model previously run, as it accounts for the concept of conditional convergence between countries. The results of this robustness check also validates the research question, but the magnitude is higher. Here, a 10% increase in universities is associated with a 1.6% increase in long-run GDP per capita, which is much higher than the 0.4% previously stated. This suggests that the previous methodology has a risk of underestimating the effects of the number of universities on GDP growth.
To summarize this paper in discussion, the authors found strong empirical evidence that the increase in universities has a significant positive effect at driving economic growth within a region and in the neighboring regions. Various robustness checks validate their findings. The mechanism behind this causal relationship is not driven by demand, but analysis on the control variables prove a more pivotal role of human capital supply and innovation at boosting economic growth. The most prominent underlying mechanism this paper unveiled is the effect of universities on democratic values in the region, but it seems to have a longer-term effect. The main part of the analysis employed a 5-year lag, but when the analysis is replicated with a 10-year and 25-year lag, the effects are smaller, but remain highly significant. This may be suggestive that there are more factors at play in the long run that the current framework can't capture. Furthermore, despite the robustness of the results, this paper lacked an instrumental variable to rule out endogeneity issues. For instance, if the government were to implement expansionary policies, this would have confounded the measure of GDP in the model, and the authors were unable to fully isolate the causal effects of universities on economic growth. In conclusion, despite its limitations, Dr. Valero and Dr. Varini's research has significantly enriched the scholarly discourse on the economic impact of universities, as their research marks a contribution to our understanding of the profound influence universities wield on economic dynamics. Their valuable insights not only expand the current literature, but also lay a robust foundation for exploring growth effects in areas of future research and for policymakers in deciding education funding. With that, our discussion of this research paper has come to an end. Thank you.